Hello, hello. How is everybody today? There we go.
Afternoon, Jason.
Afternoon.
Everything's good.
Greg, good to hear from you again. How have things been?
Decent.
Excellent, excellent. Like what I like to hear. Hope everybody had a good Memorial Day weekend. Out of sun. Long time no see.
Thank you for the nice event a few weeks ago.
Excellent, excellent. Well, glad you were able to join us. Shlomi, it's a pleasure to meet you.
Yeah. Oh, where I'm looking, this
You're-
direction.
Are you in Malaga? Your LinkedIn says you're in Malaga. Do you work with
Yeah, I used to be in Malaga, but I moved to Germany just recently. So I'm now in Stuttgart, close to our headquarters in Bublingen.
Well, I hope you didn't move for the weather because the weather's a little better in Malaga.
I just read in the news today that it's going to be 40 degrees this week. So
Oh, wow.
for me, it's nice now. Yeah, it's too hot.
Yeah, we had a great time. Did you come to one of the plug fests in Malaga? Did I happen to see you there?
Yeah, I was there. I was there meeting Bill McKinley at one time. I think it was last year, but I think it was the 5GA kind of thing.
Yeah, we did two. We did one in 2019 and
Yeah.
one
Oh, okay.
last year. I think last year. And just a fantastic venue.
Yeah, amazing. Yeah, I like being there a lot. It's I didn't live there because of the good life there and the weather. I left because now automotive is calling me, and this is where the headquarters. So
Oh,
I
sure,
need
right.
to
That's
be
where the
here.
business is. That's where the business is. Well,
Yeah,
Bill's trying to
absolutely.
convince us to come to Scotland for meetings. He says the weather's better than Mulligan, but I'm not really sure.
Really quick, let me just for 1 second, if you want to continue doing welcoming, Jason, 1 sec. Thank you.
Sure.
Show me if you can join me in the breakout room.
Okay, very good. We usually give it to about 2 minutes after, and then pretend I'll ask you to just pull up the slides. Roy, good to see you, sir.
Hello.
Hey, okay.
Just really quick,
Camera here.
you try to share your screen with me real quick. I just want to make sure that
Yeah,
I'm going
let's
to
do it.
I will give you access.
Yeah.
So you should have access now.
Okay, I'm sharing my screen. Sure. Let me see if I go full screen. Let me see, it's staying here.
Do the slideshow view. So slideshow, and then.
Yeah, I'm running slideshow. Oh, you see, it's different. I need to move to the other one.
Got it.
How do I change here? It's display settings. Whoa. Okay, so now it's fine.
Yep, looks good.
Yeah, easy.
All right. Thank you so much. So let's let's head back into the meeting. We'll talk to you in a little bit at the end.
Okay.
Thank you.
Thanks.
Thanks for joining us.
I just got off of a
Jason, do you hear me?
Yes, we hear you. Yes, welcome. Rakinda is just getting the slides set up. And I think we are about 2 minutes after. Let's go ahead and get started. I'm sure we'll just let people join us as they come in.
All right, welcome everybody. Let's start with the antitrust statement. It is the policy of the OmniAir Consortium that the organization, its officers, board of directors, members, and participants in its activities shall comply in all respects with federal and state antitrust and/or fair competition laws, regulations, rules, as may be applicable. Accordingly, no activity or discussion at any OmniAir-sponsored meeting or other function related to competition or relating to practices that may restrain trade is permitted. Such prohibited topics include establishing prices, allocating markets, encouraging boycotts, regulating production, or any other understanding or agreement that may be considered as anti-competitive. Jason, turning it back to you.
Oh, there should be an agenda slide. Can you move to the agenda slide? Keep going. Okay, here we go. Here's the agenda slide. So thank you everyone for taking the time to join us. I know it's a holiday week for many in the US, but we appreciate those of you who are available and are taking the time to join us today. We wanted to give you a few updates of things happening in the OmniAir world. We'll welcome a few new members. We'll have a review of a fantastic PlugFest event that we did last week in Michigan and week before last in Michigan. And then we have a wonderful guest speaker today, Shlomi Cohen from Keysight Technologies, to talk about non-terrestrial networks used for vehicle connectivity and some of the testing implications. So I think it should be a really fascinating discussion, and I'm personally looking forward to it. So to give our guest speaker as much time as possible, let's get started without further ado.
Just 1 minute. I'm going to go ahead and stop sharing to take a look at this deck. 1 sec.
That's okay. Well, for while we wait, I just wanted to say that we're very appreciative of our hosts at University of Michigan, both at M-City and the University of Michigan Transportation Institute, for hosting a fantastic PlugFest event last week, or the week before last. We had really strong participation for devices as well as test stations. We had very good attendance at our workshop. And I certainly appreciate everyone who took the time to actively participate in the testing here. And I hope each of you had a great experience. We'll talk a little bit more as we go forward on this. Okay, let's go ahead and move past this. Can we just move to the next slide? Okay, so a couple of things that are happening in the world of OmniAir. Just before PlugFest, we launched a brand new certification program for RFID tolling. For those of you who are more familiar with OmniAir in the world of connected vehicles, you may be surprised to know that we started our life in the tolling world. We're an outgrowth of the tolling industry, and we were originally formed to meet some of the certification needs for tolling. We continue to do that work since 2012. We've had a testing and certification program for 6C tags and readers. These are the sticker RFID tags that you'll see in Western states and Georgia and an increasing number of states around the US. And we've been doing that for some time. And we've been working for the past 4 years or so on developing some consensus testing, both conformance testing and interoperability and field testing necessary for multi-protocol tolling readers as more agencies start to move to accept 6C and CGO and TDM tags. There's an increasing need for multi-protocol readers, and then in the trucking world, multi-protocol transponders. OmniAir has been working with EasyPass Group, as well as a number of other tolling agencies, to shape a program that meets everybody's needs, meets the industry needs. And we have just launched that program on May 6th. You can click on this QR code if you're interested in applying for that. Of course, OmniAir certification is limited to our members, and we offer that testing through a network of test labs. Our newest authorized test lab for tolling is DECRA in Sterling, Virginia, and we're very proud to be partnering with DECRA on that program as well. We plan to have a webinar in the next month talking about our multi-protocol tolling certification program, so we'd certainly encourage you to watch for that when we make that announcement. And if you're in the tolling space, you'd like to learn more, just reach out to us. Next, please. And of course, that's not our only tolling certification program. We do have the existing certification program for our CV2X devices. We do this for OBUs, RSUs, and now modules. And we offer that certification through a network of laboratories around the world. TÜV Rheinland in Taiwan, TTA in Korea, and DECRA in Malaga, Spain, are all authorized test houses. If you're interested in OmniAir certification, which of course is being required in more and more RFPs that we're seeing and our members are seeing, especially for RSUs, please reach out to us and we'd be happy to help you. And you can also apply for certification directly on our website. Next, please. So before we get into our Plugfest review, I would like to welcome a couple of our newest members, the New Jersey Turnpike Authority, which if you're headed to the Jersey Shore this summer, or you're headed to New York City, you will find yourself on one of their tolled facilities. And we're so pleased to have them joining as an executive level member. Do we have Jose or any NJTA representatives on the call? Okay, very good. We also have No Traffic, which has joined. And I believe we have Roy from No Traffic.
Yes.
And they are really revolutionizing transportation. So applying AI
Hello, everyone.
thorny issues, and would like to introduce Roy to share a little bit about the No Traffic.
So, do you hear me, everyone?
Yes, we hear you.
So, it's pleasure to be here, and it's our pleasure to be part of OmniAir. So appreciating the warm welcome. So No Traffic, we are a traffic management system, which we are mainly like a mobility OS system, end-to-end with NOC service and the whole package. So it means that when we are installed in an intersection, we have like the complete system, both the control unit which control the TLC, which is the traffic light controllers, and the sensor, which is a sensor with multiple types of sensor, radar and camera, and also V2X. So we are a system that's capable of doing sensor fusion in order to detect all road users and to enable optimization of traffic around the corridors and not only in a single intersection. Our main activity currently is in the US in multiple cities and different sizes of installations, and we are growing and happy to be here.
Roy, well, thank you so much. We're so excited about that. And I would add that No Traffic was a member of OmniAir through 2019, but we're so glad that you've come back to the organization. Hope you find value here, and we look forward to gaining from your experience.
Thank you very much. Appreciate it.
Thank you very much. All right, let's move on to the next slide, please. So it appears there are two slides that are missing, but I will just speak to those very quickly. One, we have within our working groups a new interoperability certification initiative. Mick Conley is the point of contact on that. We have developed a new program scope for interoperability certification. And this is really memorializing the interoperability testing that we're already doing at Plugfests. And this would be to supplement the existing conformance assessment program for C-V2X. And so if you're interested in working on that program scope, please reach out to Mick. We would love to get your feedback and thoughts and involvement in that. And then secondly, we have an activity coming up on the 9th of June in Baltimore. Our RUC working group is holding an in-person meeting. We're doing some stakeholder outreach in conjunction with the IBTTA RUC conference, and that meeting is 4:30 p.m. Eastern on the 9th of June, and would love to get your involvement if you happen to be in Baltimore for that in the tolling industry. Please reach out to Berkenda for more information about that. So I would like to, before we go any further, I'd like to thank all of our participants last week for the Plugfest. One of the impressive things about this Plugfest is the strong participation sort of from top to bottom. We had 4 SCMS providers from around the world. We had multiple bench test solutions, including from our guest speaker, Keysight Technologies, and 3 laboratories, DECRA, TTA, and TÜV Rheinland participating. We had engineering firms, including WSP, Drive Ohio, actually crossed the border to Michigan and managed to come all that way and help us with the field testing. We're very appreciative of that. And then we had a great variety of devices under test, multiple devices from each of the companies and organizations mentioned below. We had some really, really good experience from all those involved in the testing. I'll defer to Randy Roebuck, who will talk in a few minutes about that, but I just wanted to say thank you. These Plugfests don't happen without your participation. We're already working to plan the fall Plugfest at a location to be announced later, but we're putting together something I think that will be fantastic, and I think you all will really enjoy. And so again, thank you to our participants, and thank you to our hosts, MCity and Umtree. Next, please. So in Plugfests, if anything, are an opportunity for collaboration. We have a very open environment, maybe different than some of the other plug testing events that you might see. But we have a collaborative, cooperative scenario that really helps the test equipment providers, the labs, the devices, all to improve. And that's really our goal. Did have some very good participation from the U.S. Department of Transportation. They had at least 4 individuals there, as well as some of the contractors from FHWA Saxton Labs participating in testing. We look forward to doing more work with them in the near future. But we also had some fun. Next, please. And you can see a few of the folks in action. In the upper right-hand corner, you'd see Susan Sloan from USDOT doing a listening session on the second report and order, some of the testing needed in advance of addressing some of those issues with respect to the 5.9 gigahertz band. So really good feedback there. And of course, great participation from everybody. Next, please. We also did a workshop at the University of Michigan, and Umtree was just a fantastic partner with that. We had 2 keynote speakers. We had a representative from Michigan Department of Transportation and Chief Operating Officer, and we also had a professor from College of Engineering, who also is the director of the Automotive Research Center, talking about a new collaborative project for all the transportation-related research institutes in Michigan. That was a really great event. And of course, PJ Wilkins and the director of Umtree as well. So really, really great event. And then I think we have a few of the faces on the next slide who participated. There we are. So great. What a powerhouse lineup of speakers for that event. Everyone from Keysight, T-Mobile to Southwest Research Institute, Jim Sayer from University of Michigan, whose name I forgot a little bit ago, but just a really wonderful, wonderful day. And we hope to repeat that soon. Next, please. So now we're going to go into our working group updates. And as part of that, I'll ask Randy Roebuck to provide some updates and then also speak to some of the preliminary Plugfest results. I understand that we'll have a deep dive in the next V2X technical working group meeting. But with that, Mr. Roebuck, floor is yours, sir.
Hello, guys. Can you hear me?
Yes, sir.
Okay. Thank you very much. Many people know that I've actually moved from Texas to Indiana. It is complete now. I got internet services last night, so I'll be much more available, although I was taking calls. So I'm completely out of Texas now, so after 42 years. So in the working group updates and the technical, we have a module certification scope update being reviewed at this time. There is a 740A UCAM test interface that I am under administrative formatting right now, and it will go to 14-day ballot. My guess is probably sometime in mid to late June. We do encourage people to start incorporating that in Plugfest. We only have one person to do it. It's very important in testing applications, both in bench and field, to get that implemented. Some people, one person who did implement said it was less than a week to do. And it really would move everything forward in that perspective. One of the key items that on this year we have is the device interoperability test spec. We've started it here later last year, and we'll need to put more emphasis on this summer, so we can hopefully do a dry run through it in the fall Plug Fest. The certification policy group, they've completed a first draft of the interoperability scope, and now it's currently under review. So that partners with the 774 test specification itself. And that is one of the key points for the industry itself. We have been starting ASD, or some people may know it as a VD scope, aftermarket safety device. And I actually presented on a ITS America panel with some folks here late April in that perspective. Cybersecurity in 609.2.1, the composite test CRL was published and been updated a couple times. And you can go to the SCMS Manager website to get that. That was incorporated in the certification instructions, which is 748 V7.7. It was used at the M-City Plug Fest. There were a couple devices that came, a couple folks showed the testing capabilities of from the tool perspective, 609.2.1. It is the industry and the US DOT and our desire to get this pushed forward. We do know that some of the security libraries and folks just were making that available so device manufacturers and test equipment can incorporate it. So we hope to see in the fall Plug Fest, it will be the majority of what everybody uses in moving forward. There was the 1609.2.1 test specification that was released and posted on our website. Sorry for the misspelling. The test plan has about 70 different test cases, and there's 10 that are required. That demonstrates the interoperability in the mandatory moving forward. That we have run this working group both for North America, and we also have an evening session that we repeat for our Asian folks. Next slide, please. The RFID tolling group. We completed our first joint EasyPass OmniAir certification for devices using the multi-protocol certification program. The joint news release should be coming out in a day or so. We're continuing to involve the multi-protocol testing process and automation. Every time we go through that, we learn a little bit more, and sometimes have to make slight adjustments. We did have, going through and evaluating the next NAV FCC proposal to utilize the lower end of the 90 megahertz band where the tolling transponder frequencies reside. We did have an open industry meeting that OmniAir held with NextGen in late April, where they were presenting their request. There will be a working session scheduled, the next working group meeting, which is going to be June 3rd, to discuss a response, including Mark Johnson's insight. Jason, did you want to add anything more to that?
So I would just say this, that there is a petition that has been submitted to Federal Communications Commission from NextNav. It's one of several companies in the US and around the world that have solutions for complementary PNT. So position, time, navigation, complementary to the existing GNSS. There's a lot of interest in that, even from the US DOT, about having alternatives to the somewhat vulnerable GPS system that we all rely on. However, the petition suggests reconfiguring the lower 900 megahertz band in a way that would potentially interfere with some of the spectrum that is being used for tolling. Particularly impacted would be any of those using 6C devices or SEGO devices, and possibly TDM as well. We invited NextNav to participate, to present what they were planning to our tolling working group last month, and they of course presented at IBTTA last month as well. We're now going to have an internal discussion starting on Monday, preparing for comments. I think we'll be looking at some of the more technical issues, some of the potential interference issues that should be tested against as part of that process. And we want to get feedback from the broad OmniAir community. So we've asked our counsel, Mark Johnson, to provide a summary of the petition addressing substantive and procedural issues, and then have a more detailed discussion in that working group. And that's chaired, of course, by Jake Royer. And that I think is happening at 3 p.m. Eastern on Monday, June 3rd. Hope you're able to join us for that. Back to you, Randy.
Thank you very much. On the road user charging, which is one of our newest groups and actually getting a lot of attention. They're going through and getting industry presentations. We've had 3 or 4 here in the last couple months presenting what the industry is doing in that perspective. The J32, which I should have had J3217R test cases are being developed. And also we would like to continue with the J3217, which applies to the open road tolling. But Jason did mention there's a stakeholder session that's being arranged in Baltimore Sunday, June 9th at 4:30, leveraging the IBTTA financing road using event. So hopefully a lot of people can participate in that. The aftermarket safety guys, I actually was invited and presented on a panel at ITS America Phoenix, which was in late April, with Qualcomm, Audi, Consignia, and Katie. It was a full house, had a lot of comment, and was actually discussed in multiple other sessions where really the aftermarket safety device is coming very key and moving the connected vehicle initiative forward. We are tracking and participating in the J3315 AVB requirements, where they're developing the requirements and we're developing the test cases in parallel. Hopefully can have a certification program out as quick as possible. Next slide, please. The VDAX applications. Very busy. Actually, the PlugFest itself, most of the activity was really focused around the RSUs, and the Connected Intersection Group is developing guidelines in other industry events, which we're looking to see how we can provide the testing certification aspects against that. Also in the applications, we are separating the bench and field testing depending on whether it's a V to I or V to V. And there's 3 new there's 4 test case numbers, 780, 781, 792, and 793 that are being formatted, and we'll be moving forward in that perspective. Connected intersection, they're definitely looking at the CTI 4001. It should be starting a revision of the standard update here shortly, from what I've heard from industry. Also, we have been requested by the NEMA group to provide inputs on a updated TS10 that they would like to get released by the end of this year. So they've taken the OmniAir inputs that we gave last November, incorporated it. They asked us to take a look at it, and due to our plug fest and my move, we told them that we really couldn't start addressing that until this June. And we need to give our feedback probably in the July perspective. And the last, I already mentioned about the connected intersection, which is a 7 CTI 4501 document. And then the last bullet is I'm actually presenting at the Maestro Drive Ohio conference in Columbus next Tuesday on OmniAir certification, ASDs, and getting the agencies to understand kind of what OmniAir does, what our devices really need, and where we need their participation and help. This is a gathering of a lot of the Midwest agencies.
Excellent. I would certainly encourage everyone to take advantage of that if you are at the Mastro conference next week, and hear what Randy has to say.
Okay,
Thank you
very
for
much.
this. Thank you, Randy, for that great update. And as you can tell, we have a lot of things happening in the membership. There are a lot of initiatives, and we really need more hands on deck, more volunteer members to get involved. So you or any number of people in your organization can want to work on application testing, aftermarket safety devices, connected infrastructure. So many areas where we can use some help. Get involved, click on that QR code, join a working group, or just reach out to Berkinda or myself or Randy and Ryan, and we will get you involved. So without further ado, I would like to introduce our guest presenter. I'm pretty excited about this one. Shlomi Cohen, who is the director of the automated vehicle business at Keysight Technologies and leading the automotive and energy services group. He has 20 years of experience in wireless technology testing and testing for chipsets, and just a great subject matter expertise on what are called non-terrestrial networks. So it's adding a little something to my vocabulary, satellite communications for connected vehicles. So I know there are a lot of updates in the 3GPP world on that. This has been a hot topic in some of the connected vehicle meetings that I've been to. And so I am really excited to have Shlomi come and impart some of his wisdom and hopefully enlighten all of us on what's coming in the world of connected vehicles and NTN. Mr. Cohen, the floor is yours, sir.
Jason?
Yeah.
So it looks like Shlomi has dropped. I'm actually having some strange computer glitch right now as well. I'm gonna try and reach him by phone because we spoke with him earlier, so I don't know what's happened.
Yeah, this is Bill here. Let me
Are you able to give him a call?
Yeah, let me just do that.
Have his
I
phone
don't know.
number.
I was chatting to him on Teams, just saying, hey, good luck presentation, should be interesting. He's saying, I hope it's interesting for everybody, so he was ready. So don't know. Let me go and try to reach him. Sorry about this.
Thank you.
No worries. So let me open the floor to any questions about our working group updates. Randy threw a lot of information at you while we're waiting. Are there any questions about any of those initiatives that we talked about in the working groups? Randy, can you talk a little bit while we're waiting just about that new interoperability initiative? I know it's a little confusing for folks because we always talk about interoperability through conformance. What makes this program scope we're working on different? What are we trying to accomplish in this? And then what kind of help would you like to see? Randy, you there? Well, I guess Randy is not here.
He's here.
Can you unmute?
I stepped away. What would you? Is there something you need?
So we're waiting for our guest speaker. Could you talk a little bit about that interoperability initiative and the program scope and what we're trying to accomplish?
Hey, sorry, Prakenda, this is Bill here. I've got Shlomi on the line. He says that he's been putting in a room, some kind of presentation room. He's ready to go, but
he just has to
I'm
leave.
not sure.
He just needs to leave the room. That's it.
Oh, you have to leave. You have to leave the room, Shlomi. That's it. Somehow, then you'll be back into the main. Not sure what's happened yet. Sorry
All
for
right.
this guy.
It's not a Zoom call without a little bit of a glitch.
Yeah, Zoom. The wonders of Zoom. We're all used to Teams. Something different throws us.
I was on the USDA
Are you there?
workshop. Yeah.
Oh, there he is. Yeah, there he is. Okay.
Okay.
All right. Thanks, Shlomi.
You missed the introduction. So we sang your praises a few minutes ago. But maybe just you can repeat it for yourself. Maybe introduce yourself to the group, and then and I've told them that you're going to be talking about the wonders of the NTN and what that means for connected vehicles. Floor is yours, sir. Mute. You just need to unmute. Yeah, unmute.
Ahmed.
There we go.
Yeah, always exciting to speak to myself, but yeah, it's the. All right, so thank you guys for inviting me. My name is Shlomi. I think I can start sharing and then I can speak about myself while there is something on the screen. Okay, so my name is Shlomi. I'm with Keysight since 2001, already many years. These days I'm driving the AV business in Keysight in the automotive and energy segment of our organization. Before that, I was driving the business on the mobile phones. I was driving the business of the devices and then chipsets. And lately, I've been moving to the automotive side. And I also moved myself from Spain, where I was located in the last 3 years. Now I'm in Germany, in Böblingen, where our headquarters is. So without saying more, let me take you a bit to the wonder of this new communication, which is called NTN, non-terrestrial networking. And what I will try to do in my presentation is to give you the understanding and the challenges where this technology is heading and taking us. And I'll try to focus on the automotive side, even though it's very similar, of course, to where the main users or pedestrians are using those kind of services. So let me go straight to my presentation here. It's not coming. Just a second. Okay, so a bit about those satellites that are surrounding us and the use cases of each of those. So as you may see from my presentation here, and we have satellites that are surrounding Earth in very different distances. Okay, the most familiar one that we have are those GEOs that are the one that are flying very far from Earth. Okay, and they are pretty much looking at the same spot on Earth from a very long distance. Okay, if you drew a line or just think about a lamp that you can put on Earth from that distance. So each of those, you see this one here, if you illuminate his transmission, he covers basically half of Earth, and then he goes in the speed of the Earth, so he keeps on transmitting or receiving from the same the same coverage all the time. And I will speak about those satellites and what they are used for. And then there are in the medium orbits, and those are flying in the distance of 20,000 kilometers from Earth. And those are for purposes different a bit. There are also in high distance, you need a bit more of them to cover all Earth. And then the new ones that are just now booming as we're speaking, and those are on the lower orbit. Okay, those are in the distance of 1,600 kilometers or so. And those, if you are opening a beam or a flashlight that you are transmitting toward Earth, the coverage that they are covering is very small, okay? So in order to cover the full Earth all the time, you need to mount in the skies thousands of those satellites to give a full coverage of the service that those are meant to give. Okay, and each one of the companies that are operating there are putting those few thousands of their own, so the skies is full of those satellites, and those are the ones that are used for the communications that I'm going to speak about mainly. Okay, even though also the geo ones that are very far, they have also some place on the communications that I will describe on the next slides. Oh, it's the other way around. Okay, so here are the use cases that we have for as today as we speak, the technologies that are out there. Okay, so I will start from the left side, and recently maybe you remember that Apple and others have been saying that with their mobile phones today, the new ones, you can point them into the skies, and once they are telling you that they are in contact with a satellite that passes there, you can transmit an SOS message, okay? And those are done on a very specific technology, which is not 3GPP, it's not a cellular traditional, and it's not other technologies. It's very unique to those companies that are out there. One of those examples is Iridium. Okay, so Iridium are using some specific technology, and with the same thing that you mount on the phone, you can transmit those kind of short messages. The next part, which is something that is pretty much happening now, and it's a bridge between this and to the next 3GPP implementation, and I will speak about this in my presentation, is using it's kind of flying base stations out there in the skies in the low orbit that you may use as a user, okay, your own device without any change on the device, okay, make communication seamlessly to those satellites that are out there. So that's happening with a very unique or special companies that are out there. So you can see AST and Starlink, they are using this technology, and I will speak about it soon. And something that the 3GPP is taking care of, not just the base station or the flying satellites, is how to implement on the mobile phones the ability to do those communications with the satellites. Okay, and those will be a special phones that are coming from release 17 and on to the market. And release 17 is not in the future. Release 17 is already happening now. It started on IoT, okay, on those communications that are mostly half duplex, okay? That means that you don't need to make a voice call. You just want to transmit some message about location, about the content, or something like that, about a package that is sent overseas and you would like to track it. And that doesn't require those satellites that are very low orbit, because the communication is mostly half duplex. So those are transmitted to those that are very far from Earth, and the transmission goes there. You don't care much about the latency, And that's been used today. Okay, so there are a few companies out there, like Motorola has been working with Bullet, and then MediaTek is working with Skylo and their own with some of their own mobile phones. And we have been demonstrated that, and they've been demonstrated those communications in many places that you can even Google today. The next to come is the next releases, which is 18 and so on. And those are more addressing the broadband, okay? And it's like the full services that you may have on 4G and 5G. That means that you can perform a full voice call and to surf the website, surf the net, and of course get a very decent throughput. And this is where I think also the automotive is targeting to do some usage of that technologies. And we will see also some of the automotive companies that are looking into this technology here, which is the unmodified. That means they can use today their TCUs that are mounted in the car, and they can communicate with the flying satellites there. It's going to be a special satellite that can address this. Okay, I will answer if there are questions. I will answer them later on. Okay, or you can burst and I can take those. Yeah, I listed here some of the fundamentals. Okay, in order to make those kind of communication. As I said, I took one part of that technology, and I will speak. This is the unmodified, the one in the middle that I just described. That means that how to use a regular phones or regular modules and to communicate with a satellite without any modification, and not waiting until 2030 or 2029 for those release 18 and 19 to be ready. But that comes with a lot of compensations that the mobile phone cannot handle. Okay, and I will speak about that in the next slide, and what it means for the mobile to handle those kind of distances. So we understand that those satellites that needs to be smarter, okay, all the complexity goes to the satellite, and they are transmitting and covering an area of 100 kilometers on their coverage, which is a very narrow, relatively, of course. And the Doppler that it creates is very high. I will speak about that, and of course the delay lines, the delay communication, the round trip delay is around 4 milliseconds, which is much higher than what the phone or the device can handle in today's communication. And some of the elements need to cope with that, and I will speak about those. So there are many challenges here, okay, that the communication need to handle in order to have a trusted communication, and I will speak about few of those. And release 17 and 18, as I spoke, is going to address those. But until then, let's see, and let's speak about those challenges in a more, let's say, technical discussion. So the technology we were speaking here about 4G LTE, it's easy to make the the explanation, but it's valid also for 5G. So cells and needs, when the cell is around 1 kilometer width, which is very typical to an urban cell that's transmitting in a very populated area, the phone needs to compensate this round trip of 7 microseconds with something that's called a time advance. Okay, if you are familiar with that, it's a delay that's kind of added to the communication in order to match the time that takes the communication to happen between phones that are working in different distances from the base stations. Okay, so the transmissions arrive in different timings, and the base station is aligning all these communications so it will be synchronized. Okay, and for a cell site, which is in the size of 1 kilometer, it's you see it's 7 microseconds, and then for 100 kilometers, this is the maximum size of cell. This is like in a desert. If you can think about it, there are not many base stations. So the distance that the coverage of a base station is around 100 kilometers. Okay, and the delay, the round trip delay is 667 microsecond, which is less than 1 millisecond. And I'm saying that because when a satellite is about to transmit, it's transmitting in those kind of radiuses. Okay, 600 kilometers. This is because of the distance and the way the beamforming is kind of working. And this is introducing round trip delays of around 4 milliseconds, basically. And then if you try to make just an attempt to get into the cell, it will be ignored. Why? Because the mobile phone is asking for the base station for attention, and the response comes until, you know, so late that the mobile phone is kind of ignoring that message. It's called message number 2. Okay, so this is one of the challenges that this system needs to solve, and the phone cannot solve that, so it needs to go to the base station, the flying base station, I call it. And if I look at an example here, another challenge that related to that, another challenge that's related to that is that as I said, those satellites are flying in the sky in a very high speed, okay? And they are going from one side of the visibility to the mobile until the other side. It's like 5 or 8 minutes. That's very fast. And then you can see here that the distance that the mobile phone needs to cope with is changing, because when it's in the horizon, it looks far for the mobile, and then when it's on a bore site, it's the closest, and so on. And those introducing a change of the round trip delay that can go from 4 milliseconds to 7 milliseconds. It's a huge delay that needs to compensate. And think about the processes that the phone needs to do with the base station in order to maintain the communication. There are some feedbacks that needs to go back, and those in that kind of environment are very difficult. And if we speak about that and looking forward about the frequency of the Doppler shift, and that's even worse and very hard for the mobile because of the speed of movement. And this is when the phone is static, okay? All the calculation that those companies are doing with those flying base stations, I call them, they are making all those assumptions where the phone is kind of relatively not moving. And that's very different from the automotive, which automotive is introducing a different model. And we can discuss that in the one of my last slides that we will talk about the challenges. So all of this need to be handled by the base station. Okay. Moving on. Second. Okay, handovers. Okay, so as you know, a phone is or a car or whatever moving thing is moving from a place to place, and handovers need to happen. And with the communication of NTN, that brings a different complexity, because now not just the unit is moving the device, but also the base stations are moving. So there is an NTN to NTN handovers. That means one satellite is moving above us, and then it's starting to disappear in the skies, and then another one coming in, and the device needs to do a handover. Okay, that means it needs to maintain the communication and connect to the next one. And in the case of unmodified communication, that's need to be handled by the base station itself, not the mobile, because the mobile thinks that he's communicating with the regular base station. He doesn't know even that he's communicating with satellites. And then other cases when there is an NTN to TN, that means that when a phone is connected to a terrestrial network, and then he lost it goes out of the range of the base station's coverage, and then it needs to camp on the new satellites or the new communication that covered by the satellites, and then it's called TN to NTN handovers. And then there is the other one, which is it's about the location of the base station of the mobile and the location of the satellite, and that's another use case, which is more for testing and less for real life. But I can just cover it here because those are the things that we are kind of covering with our testing systems. Okay, so this is a bit of scenarios. It's mostly just to illustrate what kind of KPIs are expected when going into a base station or into an NTN kind of use cases. So as I said, the DOT is in the middle of the cell coverage, and then the cell is moving above. And with all those parameters that I just been speaking about, the delays are changing and the Dopplers, and then it starts to lose a communication with the satellite, and he sees another satellite which he thinks this is a regular base station that's coming into it, and then it needs to do some calculation and do a handover. And this is a scenario that needs to be tested, and all this need to be tested while there is a service happening, like a throughput measurement or any other service or use case that you may think that is relevant for automotive or others. Let's say like updating the car firmware. Okay, like there are some of those services that are aimed for satellite to provide. If the car is taking out from the area where there is a terrestrial networking coverage, you would like to make a continuity of this service, that it will not stop in the middle and will cut off the updates, or downloading a map to the car in a certain area. So all those use cases would needed to be tested while the handovers are happening. Okay, and this is satellite to satellite. Another thing that need to be tested is the same satellite, which is changing beams. Okay, the satellite has a beam that's transmitted to a certain area. Okay, and it also can do a coverage of another area, which is it's capable of, and we will see some of those huge satellites. I think AST has been delivering one of those satellites out in the skies, and it's in the size of I think like 20 by 20 meters. It's a huge satellite because they need to do those beaming, and they need to do this focusing of those beams and to handle those handovers. So those are the kind of challenges that we are trying as a Keysight to address with our portfolio. Okay, and this is very complex scenarios, and there are coming more difficulties and challenges that the technology is bringing, and I just put it here as an area for thinking. Okay, and one of them is the use of very high frequencies above 10 gigahertz, and those are the K and Ka bands. Okay, today they are supported on the VSAT, where the cars are, lifting this huge dish, and that's how they're communicating in those frequencies. But that does not fit for normal cars, of course, to go with this huge dish. So that's going to be replaced by a phased array antenna that will be mounted on a car. And that's kind of the practicality of how to do that. And it brings also some difficulties, which is the plate of the car, which is made of aluminum or others that are making a lot of reflections. And the size is 20 by 20. Where do you mount it? If the car is sporty car or small car, where do you put those antennas? And so on. But the main problem, I think, in the main concern of the industry is that the automotive, at least the OEMs, are not so happy or are not so familiar working on millimeter wave in communications. They are working on high frequencies when it's related to the radars of the car, but not on the communications. And they're prevented going into that direction even on 5G. So all the communications are done below 6 gigahertz. And the more problematic with the money thing or the investment, that all the environments of testing need to be changed. Think of a complete car that need to put in a chamber that is been designed for 6 gigahertz or up to 10 gigahertz, and now you need to work on 13, 14, or 20 gigahertz. That's a full investment that need to be taken, from those companies to build a full-blown chambers and antennas, and all the instruments need to change, and the paradigm is changing completely, and those are huge investment. So I think the industry is about pushing that back and trying to keep working on the S and L band. Those are like the sub 6 gigahertz. It's around the 200 and not 200, but 2 gigahertz frequencies, and below a bit, and that's still there. Okay, so it's in order to use wide bandwidths, in order to deliver use cases of high throughputs, and the same like you have on a mobile phone when you are today in 5G inside a car. Might be that the industry will need to go to that direction, because the bandwidths that are available today in sub-6 are very limited. Okay, and then the vehicle's speed or movement has not been taking care much on the unmodified technology. It's mostly targeting users that are pedestrians and less moving cars. But that's a valid technology that's happening today. There is a lot of hype around that, and the investment from the OEMs is very small. Okay, you don't need to do nothing. You just need to subscribe to one of the operators that you are working with that gives those frequencies to that satellite company, and that's pretty much it. But this technology is very risky, because when the car is moving, it introduces more variants than the technology was designed for. And if you are taking it also to handovers between countries, on borders of countries or operators, then it brings more complexity how to maintain those roaming agreements and continuity. And all those need to be tested, of course, in a lab before going out, and then to do all those test cases in the field. And that will increase, of course, the cost of all the car testings and so on. So in one hand, this is exciting technology, and I'll just touch here one path of this NTN, and there are additional 2 ones that I will need probably 3 more hours just to speak briefly about those. And I would like to pause here, and this is kind of just the taste of where this is going. Of course, Keysight has a lot to address in this market. I didn't want to put all the solutions from Keysight, because I try to make it more like a technology brief and less about promoting the solutions. So I will pause here, and I'm open to have questions. Some of them I can answer now, and some of them I may need to take and to come back to you guys afterwards.
Well, Shlomi, thank you so much. That was very insightful. And that was a real whirlwind through a little bit of a challenging topic, but an exciting one we're all going to deal with. So maybe just a level set, and I'll invite everyone to put their questions in the chat box. I see we have one already. But let me maybe just start the level set. What are some of the more exciting use cases that you're seeing? What's coming on the horizon? We've seen, you talked about some of the 3GPP standards that are ready now. What are we going to see in the next couple of years deployed to that?
Yeah. So I didn't maybe say I'm part of 5G and I'm working on the work item of NTN RAS, and there we are kind of defining the use cases that will be used and the 5GA decided to go only on 3GPP. Okay, they are not talking nothing about other technologies that are out there. And the use cases that are showing up or we are kind of working on are starting from narrowband services, which are emergency things that needs to go out. And in the future, this is where the main thing will happen, where the broadband services will be available on release 18 and 19 of the 3GPP. And that will happen in 2013. 2030. This is where the market is kind of waiting for all the ecosystem to work together, and then that can be executable. But the thing is that we already see today few of the biggest OEMs coming to us to address the unmodified technology. That means they would like to use the current, the current TCUs in the car in order to give services of mapping, downloads. All the services will be seamless. Whatever you have in the infotainment system will be used either via satellite or via the base stations that are on the ground. That's
really,
where they
with infotainment, is that really the kind of the starting point? What we'll see in the very near term.
Yeah, this is what they're trying to address. It's still early stages. They would like to have their infotainment seamlessly working in every place. Like no matter where you are on the globe, you will get service. Okay, so that's kind of the test model. And another thing, just before that, we see also few of the very luxurious, I cannot say names, but luxurious OEMs that would like also to use the unmodified, not so unmodified, the proprietary services. That I mean, if you go for SpaceX, they are transmitting their internet over a very unique IP that they have, and it's not 3GPP, not nothing else. But they are approaching OEMs and they are proposing those kind of services. And this is also a challenge area because the antennas are huge. As you know, it's like a laptop, and it's a services of internet in a very high speed. Okay, so you can take that to many use cases of entertainment in a car, like you can watch TV and broadcast and whatever internet services in a vehicle, which is kind of maybe a luxury one that they can do that.
And then you talked a little bit about public safety use cases. Do we think we'll see that in the next 5 years or so?
Yeah, I think for safety, I can say e-calls, yes, but nothing which it's reliable to make decisions on a car. I don't think that those delays you can make a decision like stopping a car or maybe a bit of downloading maps and so on, or something in a very long distances, maybe a traffic jam that's somewhere out there. But I don't think that it can replace those device-to-device communications. Okay, I don't think so. I don't see that coming with those milliseconds of decisions. So it will not go to that direction, but it can give a car ability to create an e-call or emergency, whatever, in a much more reliable way without leaning on the 2G, 3G or whatever.
Yeah, we like to think that there's ubiquitous network coverage everywhere in the world, but not always the case. And so I could see some lives being saved by the seamless and ubiquitous connectivity, even in some of those use cases you talked about. So
Yes.
Really exciting stuff. Hey, I'm going to open the floor to questions. I see that Alex Chang put one in the chat box. Why the satellite communications now? I missed the issues on 3GPP RAN 5. Could you explain a little bit about the background of satellite communication? Can we beat all the delay in the road?
Wow! Again, it was fast for me. I'm not the American native. Just to keep it. Can you read it again, please? I will capture the question.
I'm translating from Korean to English, to whatever. So why the satellite communications now? I might miss any issues on the 3GPP RAN 5. Could you explain a little bit about the background of satellite communications? Can we beat the delay in the road? And Alex, if you're on the call, you're welcome to elaborate.
Still on the line?
That's okay. All right, but
Okay, so if I would, yeah, so I will try to explain what I understood kind of the question. So 3GPP is addressing, you know, you need, if you take this technology, if I'll take backwards this thing, okay, or you know what, the first table. Okay, if you take this table and you say, I would like to make a communication with cellular, none of those delays that is being introduced here, where are those round trip delays can match to cellular. That means it cannot happen. Okay, so 3GPP kind of took the challenge and they said, okay, how we are going to cope with those delays and Dopplers that are happening there. So they added to the protocol several things. First of all, they added some system messages that are coming, and they are giving to the phone exactly where the satellite is, what is the frequencies, what are the Dopplers. They know more, and they compensate in the protocol all those things so the communication can still run, and the UE will, the phone will be the one that will compensate all those parameters in order to make it happen or make it work reliably. Okay, this is where 3GPP is taking it. 3GPP is responsible for the UE, let's say. Okay, in that sense. And what I was talking about was not 3GPP. It was a company that says, okay, I will build a satellite that will take care of all those problems, and the phone doesn't need even to know that it's talking to a satellite. Okay, so it will, you know, it compensate about the delays, compensate about the Doppler and so on. Okay, and those are IPs. It's a communication of cellular with a lot of intellectual properties that they are holding and are not sharing, not even with us. Okay, we are learning from with the tools that we have how they are operating, and we have collaboration with them, but they're keeping their secrets very close to the chest. Okay, so we need to learn from the practicality and bringing it into the simulation so we can simulate what they're doing. I hope I answered.
No, that's great. That's great. Do we have any other questions? Open the floor to our members. Just raise your hand or go ahead and shout out.
Yeah. Anyway, I think the slides are shareable, and I'm even afterwards I can take questions even offline from people if they are shy in that group.
Well, thank you. So maybe just one parting question. So we are a testing and certification organization. We have a lot of our members are in the test and measurement industry, a number of test laboratories. I mean, as this technology is evolving and starting to hit the marketplace, what are some of the test laboratories and research institutions that are involved in testing should really start thinking about? How do you prepare for this coming world?
Okay. Thank you for the question. I think it's very, very well in the place. So once it's 3GPP, okay, we can standardize it and certify it. Okay. Once it's not, we have no play there. It's between the two companies that are making the communication. If it's not 3GPP, okay. And so for the 3GPP version of the NTN, okay, there are a few players that decided to do certification, and one of the biggest one is Skylo. Okay, Skylo is one of the operators of the satellites, and they have published a list of requirements to the market, and everybody that would like to connect to that network needs to go through certification. It's like they publish some, I don't know, hundreds of test cases, and we are, as partners of them, you know, publishing also those test cases to the market, and people that would like to run those and to be accepted by Skylo needs to go to those test cases and run them. Right now it's IoT only, it's narrowband IoT, but in the future it will be also for broadband services it of course needs to have all the constellation of the skies in place, and of course before they're offering those services. So this is my answer about certification.
Oh, excellent, excellent. Well, thank you so much. One last chance for folks. I know it's a deep topic. Any other questions? Final question, does that mean that we are all ubiquitously connected now in our cars? If Bill is running around the wilds of the Highlands of Scotland, are you saying that his boss can reach him at any time, in any place? There'll be nowhere to escape?
I hope not.
I
really hope not.
Yeah, I think if you go a bit online and go and search news about, just put AST and you see this is the satellite in the sky. This is a huge plate that goes out there, and this is one of those things. And also, if you are interested, I think this is what makes this market very mature. That I think every 2 days there is a SpaceX are broadcasting live their shuttle goes to space, and it mainly goes to put and plant more satellites. Okay, I think they are planning to put there like tens of thousands of satellites. So yeah, to cover every time that they are launching is around 20 to 30. And you can see that in the skies. You see a line of light going, and they are putting themselves in their position. They're starting to roll around the world in low orbit. So this is just one operator, and think about all the others. So I think if we are bothered about the sun, I think in 20 years from now, we will have a shade all the time because we will be covered by satellites.
I think we'll almost solve the climate change problem at the same time.
There is, you are building
Fantastic. Thank you, Shlomi. That's excellent. I think our members will certainly appreciate sharing the slides, and we appreciate your time and imparting your wisdom to us. And our next monthly membership meeting will be the 4th Thursday of June. We'll have an announcement on a speaker very soon. But Shlomi, thank you again. Excellent. And I wish everyone just a wonderful rest of the week. And reach out if you have any questions. Thank you.
Yes. Bye-bye.